All right. All right, so here we have our spreadsheet. And we've got all this junk in my way. With some data. All right. Just a few simple things just to start, right? We used basically rulers to collect these data. So those numbers are in millimeters. I've got the units here. Let's just look at what we have here. Here's a spreadsheet. A spreadsheet is just a table of cells. These are cells, each individual little box. And a cell has an address, and that address is determined by its row number, the intersection of its row number and its column letter, right? So this is cell E9, right? I'm going to start out, and it should be pretty, hopefully a lot of you know this, but we're going to move on, all right? You're going to learn something, hopefully, even at the beginning, and then we're going to get into some more sophisticated stuff. All right. My spreadsheet has a name. I can click in there and change that. All right. The other thing I have here is within this file, I've got multiple sheets. So here's sheet 1, sheet 2, sheet 3, sheet 4. I can add a sheet. I can give that sheet a name. All right. Some quick making your sheet look pretty, okay? Not necessary. But notice that my columns aren't wide enough to contain the labels, the column names. So row number 1 contains a label for what is in that column, right? Column C, the label is standard length. These are measures of standard length, which is now in the retrieval column at standard length. All right, you can see that my columns aren't wide enough. One thing that you can widen or narrow these columns by just, if I hover over one of those little vertical lines, you see the icon change, and then I can just click down and I can make it wider, or I can make it narrower. But another thing I can do is I can double click on it. So I'm just going to take that and I'm just going to double click. Wow. Let's see if this works. Let's try this. No. All right. What that I thought the behavior was going to do would that like just automatically widen to accommodate that the length, right? That may be a difference in behavior between Excel and Google Sheets. So I'm just going to widen that like that. You can see I'm widening all of them simultaneously. All right. I can make it nicer. I can do things like, if I want, I can make oh, that's why. There we go. I'll show you what I did in just a second. There we go. If this were a new sheet, if I hadn't messed with it before, my double click would have worked. All right. So let me just show you what I've done. I'm going to double click on any of them, and it'll just widen them to accommodate whatever the widest intervals in that column. Right. That's a pretty quick, very well. Another way I can make this clean is by wrapping the text, making the text flow to a new line. So for example, what if I don't want a really long column F, left pelvic spine length? What if I just want those to be shorter, right? So I can take that text, and I can go to that little symbol right there, text wrapping, and I can wrap it like that. And now you see that it's wrapped. So it had been wrapped. That's why my first double click failed, right? I can do that for all of those, make it look nice. And now I can do something like make these columns a little bit shorter, and I can even center. All right. And I've got something a little bit prettier. So all of that is just aesthetic, right? Just making it look nicer. But if you want to use something like Google Sheets or Excel to create a table that you're going to give to somebody, you want your table to look nice, right? That will reflect on how you care about the product you produce, right? If you have a job at IDEX and you're asked to make a table with something and you give them an ugly table, you're going to just get fired. All right. So exactly. All right. My measures are in millimeters. All right. I don't have the units here. I actually should have the units there. So I'm going to just add them, for example, into that column name there. Note that if I had measured this with a digital caliper, I might have a lot of decimal places. So maybe I have a measurement that is something like 13.9837. I don't even know what I'm reading, right? Something like that. In general, you might want to keep these decimal places, but the decimal places imply that your precision of measurement is much greater than it really is in your measurement. You can't measure with a caliper or ruler something as precise to that many digits. All right. So some of the things you might want to do is just, you can use these two icons here, which just control the number of decimal places to show, right? So I'm just, maybe we've measured it down to we have the precision to measure it at 100 millimeters. That would be pretty precise, right? Another nice thing to know about. So significant digits, right? You learn significant digits at some point in math class before you come to college. Certainly in chemistry, my guess is chemistry department emphasizes significant digits a lot, right? Biology doesn't tend to emphasize significant digits. And I see a lot of biologists, PhD level biologists that are out, they're professors, they're at a medical school or professor wherever, and they publish these tables with lots of decimal places. And those numbers are meaningless because they didn't measure with that precision. All right. I've got here a column called ID. Let me just show you a couple of things. I'll show you how I made this column. I'm going to just erase all of that. This is just the ID of the fish, right? How I made this column was I put a 1 in the first row, and then I just put this formula. So here's the first example of a formula. All formulas in a spreadsheet start with an equal sign. And now I'm just going to put some math in it. All right. Well, I'm going to put some easy math. 1 plus 1. Right? That's the number 2. That's a pretty good ID. It's the second fish. We could call it fish number 2. All right. But there's not a lot that I can do with that formula, or I should say that's an inelegant way to do that in a spreadsheet. What I'd really like to do with it is something like this. I'm going to put the equal sign in, and then I'm going to just click in the cell above it, right? And you can see that, first of all, Google Sheets is trying to fill out this, it's trying to guess what I'm trying to do, right? So it's giving me a bunch of stuff. But you see when I clicked in it, let me take away Google Sheets there. It put the cell address of the cell that I clicked into. That address is A2. So my formula is referring to the entry in cell A2, right? So A2 is the cell just above where I'm putting the formula, right? The value in there is 1. Now all I want to do is just add the number 1 to that, right? And I get the number 2. So I have a formula. Take whatever number's in the cell above me and add 1, right? I want to do the same thing here. I want to take whatever's above it and just add 1. So I'm going to put equal, click above it, add 1, right? I could just do that for every cell below, and it would work fine, but that's a pretty inefficient way to use a spreadsheet. Excel and Google Sheets have really nice mechanisms for making behaviors like that quick. So look what I'm going to do, right? I've got this formula in cell A3. I'm going to grab that little handle. See that little blue square in the bottom right corner of the highlighted box? I'm just going to click on it. I'm going to shift click. I'm going to click on it and hold on it, and then I'm going to just drag it down. All right. And look what it did. Let's just click on the next cell, cell A4, and you can see its formula looks the same, or it's the exact same. It's take the cell above it and add 1, right? So notice that in cell A3, it's referring to the cell above it is cell A2. And now if I click down into cell A4, the cell above it is cell A3. There it is, A3. So the formula has changed as I've pasted or filled this formula down. The formula has changed in a way that it's doing exactly what I want to do, right? So this is a fill down. I filled this formula down, and the reference, the absolute reference changes, but what that reference is doing hasn't changed at all. The reference is take the cell above it and just add 1. Take the number in the cell above it and add 1, right? Super nice and easy. That's really easy to do. Google Sheets and Excel have even easier ways of doing stuff like this. If I just want a column of numbers all in order, I can do something like this. Actually, let me erase these. Right? There's 1, there's 2, there's 3. I'm just going to take 1, 2, and 3, and I'm going to drag it down. I didn't even put a formula in. Right? Sometimes I do this, sometimes I don't. If I add rows to it, I don't have a formula to drag those down, right? So sometimes I do that, sometimes I don't. It can even be we can even get more fancy. I can do something like this. Maybe I don't want to just save my fish or ID 1 through 20. Probably they aren't, right? I'm not going to have a jar with a label on a fish that starts at number 11. I'm going to have a jar of freshwater fish, and I want those to be 1 through 50, and a jar of marine fish, and I want those to be 1 through 50, right? So we could do something like this. I'm just going to erase it again. I'm going to put freshwater 1, freshwater 2. See if that works. Nice. And I'm just going to drag it down to the end of freshwater. And I'm going to put marine MAR 1 and MAR 2. And I'm going to drag that down. Oh, it thinks it's March. Did you notice that it changed MAR? It capitalized it, didn't capitalize my FW, right? A super, super annoying thing about Google Sheets and Excel is they think certain numbers are dates, and they think certain abbreviations are months or days. There are famous errors in analyses when there are certain gene names that Excel thinks is a date. And so people have done analyses in Excel, and the analysis has been wrong because Excel is reading the name of a gene as, March 15th. Right? Anyway, so sometimes Excel and Google Sheets, they're usually pretty good at guessing what you want to do. That one's really annoying for biologists. And has led into some really famous analytical errors, people analyzing stuff in Excel. All right. So there I've got some, let's at least make it consistent. Freshwater 1, freshwater 2. There we go. All right. So now maybe in my jar, I actually have a label attached to a fish, and it's FW1. All right. One thing that I like to do, notice that if I scroll up, I lose the column names. I always want to see my column names, and I often have rows that I want to see the names of those too. So in Google Sheets, I do something like this. I'm just going to highlight row 1, and then I'm going to go up to View, Freeze 1 row. And look what the behavior is. So I'm going to freeze 1 row. Now look, when I scroll up, those column names stay there. That's super useful, right? You can freeze as many rows as you want. Typically 1, 2, 3. That's a nice trick to help you navigate through big sheets. All right. We can even do something like we can freeze column 1. All right. So now if I scroll this way, I can see there's lateral plate count for freshwater fish 1, for FW1. Right? Super nice. All right. Let's make some more calculations. So you're going to be making calculations like this. Let's make a simple calculation. I'm going to calculate. So this is freshwater fish. And I want to calculate the mean. All right. The mean is the sum of a bunch of numbers divided by the number of things that you sum. So we can make a formula for that. I want to take the mean of standard length for all of these fish. So I'm just going to click there, add a plus sign, 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 click there, as a plus sign, there, plus, there, plus, there, plus, close my parentheses, and divide by 10. And I get an error. Where's my error? There we go. All right. We can do that. It was pretty quick. I had 10 fish. What if I had 1,000 fish? That would be take me a long time to do that. So we certainly could, but we can see a formula, right? If I click in here, here's my formula bar up here. There's my formula. I'm going to do another thing here. I'm just going to make this bigger so you can see. I'm going to make my whole screen bigger. Right? So there's, I'm clicked in this cell. That cell is showing a number, But if I go up here, you can see that what's actually in the cell is not that number. What's actually in the cell is that formula. All right? But it's displaying the number. The cool thing about that is if I change, it's a dynamic. C11, that value is in that formula. So if I change this number, this will change. Right? So let's make this really big, 100. Right? And we see that number changed. So we can update the calculations really, really quickly. Right? One thing that I want to say, and now's a good time to say it. Who here uses a calculator? You have to use a calculator in chemistry? You use chemistry? Yeah. Chemistry is a really nice and rigorous program, but calculators should be thrown out of science, right? Calculators became obsolete 40 years ago, right? Once desktop computers became pretty common, right? Common enough. We'll say mid 1980s. There's numerous problems with a calculator, right? One is you don't know what numbers you actually typed into it. So you're typing some numbers into it and you get a result and you write the result down in your lab book. How do you know you didn't make a mistake in the number you typed? Right. Number two, the formula you use could be wrong. So remember, there's a certain order of operations in math. Things like A times B plus C. Which one of those operations do you do first? Let's do this. A plus B times C. Which one do you do first? Or even worse, right? A plus B divided by C. Right? We do multiplying and division first, and then we add and subtract. Sometimes we need to use parentheses in order to maintain that order of operations. So how do you know the order of operations that you did in your calculator was correct? Right? You don't. You just have to have faith that you did it correctly. You get an answer, but is it the correct answer? Right? When you use a spreadsheet, you have the data that goes into a calculation, and you have the calculation. If you're getting some weird numbers, right, with a calculator, like you do some work, and whenever we make calculations, we need to always check, are these calculations what I expect? We always have some kind of an expectation of what a result is. And we're looking at these and we're like, no, I made a mistake. If you did that calculation in a calculator, you don't know where that mistake was. If your calculation is in a spreadsheet, you have your data that goes in and you have the formulas, you can check that. Is it the data? Is it the formula? You have an archive. Right? That is unbelievably valued to the replicability of science. Calculators are so dangerous to the replicability of science. They should have just been burned, and they should have been sold starting 40 years ago. Right? They're really, they teach bad practices. One of the things we want to do in science is we don't want to do bad practices. Right? Mistakes are always made in science. Everybody makes mistakes. So we want to use workflows that minimize the possibility of making mistakes. We're never going to get rid of mistakes, but we want to use workflows and strategies that minimize the probability of a mistake occurring, right? So calculators are a big one, get rid of them. All right. Here's a nice thing about a spreadsheet. What if the machine that gave you your data was a little bit off? And so you have a correction factor, or you're redoing some data points. you have all these calculations in your spreadsheet and it just automatically updates. If you're using a calculator, you gotta do it all over again. Right? So it's just inefficient. All right. So there's one way of taking the mean. That's not a very good way. You don't want to take a mean that way because it's just you're clicking a bunch of numbers and it's pretty easy to like forget one. All right. So that's not a good workflow for minimizing the probability of mistakes. So we could use here's another way we could compute a mean. Excel has functions, right? So at this point, I've just used math operators, like a plus sign or a division, right? Those are math operators. But Excel has functions. A function is this. The function has a name, and then it has parentheses. And in the parentheses, it has what are called arguments. And some functions may only have one argument. Some functions may have a bunch of arguments. Arguments are things that you send to that function that tell that function some information, how you want this computed. All right? So there's a function called sum. And the argument is simply the range. It's a single argument, and it's just the range of the numbers that you want to sum up. Right? We're going to use in this class a function called t.test. And it has 4 arguments. It has the range of the one set of data that you want to compare. It has the range of a second set of data that you want to compare. It has a third argument, which is just the type of the t-test you want. There are 3 different kinds of t-tests. So you might just put a 2 there because you want the type specified by number 2. For that, you have to actually know what 1, 2, and 3 specify. All right. And then it has another argument for you want it to be a 1-tail or 2-tail t-test. We're going to learn about that later, but there's 4 different arguments now that you need to set. All right, so we can compute the mean using some Excel functions. So I'm going to put my equal sign. I'm going to put SUM, and then I need to give it the range of the numbers that I want to sum up, right? So what I'm going to do is I'm just going to click on the first cell of that range, and I'm going to hold it down, and I'm going to drag to the last number. All right. And then I'm going to close that parentheses. Let's just put sum for right now. All right. Here's the range. It's the address of the first cell, colon, address of the second cell. Sorry, address of the last cell, right? So the colon means every cell in between these 2 at the end of the range, right? So I can take that sum and I can divide it by 10 and I can get the mean. Here's another thing that you shouldn't do, all right? Don't hard code variables. That denominator is a variable. Think about what a variable is. A variable is something that can change, right? I hard coded it. I put a number there, 10. What if I delete one of those rows? The denominator is going to stay 10. So it'll be wrong. A better way to do it is to use the function count. So instead of 10, I'm going to use the function count. And it's the same range. So I could go up and click and drag and highlight it. Or I can just, I've got the range right there, C2 colon C11. So I can just put C2 colon C11, right? Notice that I put it in lowercase. Google Sheets, Excel is smart enough to know what that is, right? And when we go back up, you can see it's changed it to uppercase, the C2, C11, right? So there we have the sum over the count. That's pretty easy, right? I'm mostly showing you that because I wanted to show you count. When you count something, use the count function. Don't count it manually in your head and put that number. So that's another rule with minimizing, using strategies to minimize probability mistakes. Don't do calculations in your head. Excel, Google Sheets is a calculator. That does the calculations for you. Don't do calculations in your head, even if it's really simple. You see two numbers, it's really easy for you to just sum them in your head. Don't do that. Let the sheet make that calculation. Just get into that habit. Don't do calculations in your head, right? So in addition to throwing away your calculator, throw away your brain, right? Or at least the math part of your brain. So you don't do calculations in your head. All right. A nice thing about a spreadsheet is we don't actually have to do the sum over the count. We can actually just, there is a function for the mean of a set of numbers. And that function is not mean, but average, right? A mean and an average are synonyms. So here I'm just going to put equals. It's already wants me to do it. Average, it heard me. It's listening to my lecture. It heard me, and it put average there. So I'm going to put the function average, and I'm going to drag down, close my parentheses, and there we go. All right, super simple. Right? Probably want to use, if Google Sheets or Excel has a function for something, you probably just want to use it instead of doing the calculation yourself. Right? I'm going to compute something called the standard deviation. Very famously, when Excel first came out, it gave, I don't want to say the wrong formula for the standard deviation, but the formula that nobody uses. And so it gave an answer that nobody expected. All right. And so people were getting, again, wrong results because actually Excel's own formula was incorrect. I discovered that. I started using Excel when it came out because I computed standard deviations by hand in Excel and then checked it with Excel's function, just what we're going to do right now. And then I got different numbers. All right. All right. So let's do this. Let's get rid of these two columns, these two rows, because we don't need them. They're just redundant. So I'm going to go up to edit. I'm going to go up to delete, and I'm going to delete rows 24, 25. All right. We're going to talk about variability and statistical measures of variability. So we all have a good sense of what variability is. Variability is differences, right? So you see some numbers here. If we look at standard length, this is the length of the fish, right? We see that there's variation in these numbers. Oops, that 100 is not real. I don't know what it was, but clearly, I think it was 65. But I can go back in, right? So I should have changed that right back, but it doesn't matter because it's just a demo data set. All right, so there's variability. There's two measures that we use a lot. A quantitative measure of how variable a set of numbers is, distance. Okay. One of those numbers is called the variance. And one of those numbers is called the standard deviation. Right? And standard deviation is just the square root of that. We're going to talk about what those are later. That's going to be another better know assignment. Right? So I'm just going to use standard deviation. I'm just going to put SD, and Google Sheets has a function for standard deviation, STDEV, standard deviation. And I just need to give it the range of numbers. All right. There's a good example of way too many significant digits. That gives our reader the sense that we're much more precise than we really are. So let's get rid of that and make it one more than we actually have. All right. I want to compute the mean and the standard deviation for every one of these measures. On these fish, we've measured the length of the fish. We've measured the depth of the fish at spine 1. We've measured the depth at spine 2. We've measured the length of the dorsal spine. We've measured the length of the pelvic spine, and we've counted the number of lateral planes. So I want the mean and the standard deviation for all of these. I could, right, just put that formula in each one of these cells. But Excel and a spreadsheet gives us a very convenient way of doing that automatically. And that's by that fill down or fill across, fill a formula down, fill it across, and let the cell that it's referring to move with it. So right now, my formula is referring to rows 2 through 11 in column C. So if I grab that little handle and I just move it to the right, if I look in there, I've moved the formula to the right. The rows stay the same, still 2 through 11. But notice that the column now has shifted over from C to D. All right. So now it's taking the mean of the measures in D2 through D11 instead of C2 through C11. So that's super convenient. I don't have to retype that formula, right? And I can just do that in one shot. I can grab both of those, grab the handle, and just move it over. And now I have the mean and the standard deviation for all of those columns, right, of the crash water thing. Super nice, super convenient. All right, that fill down, fill across, that grabbing the handle, it's a really nice, convenient tool in a spreadsheet. All right. I'm going to get rid of these marine fish. I want to show you a little bit more powerful way that we can use that fill down and fill across. So I'm going to compute a standard deviation by hand. All right. I'm going to compute it manually. So a standard deviation is this. The formula for standard deviation. We're going to sum each value. Let me just write the formula first. Right? So in the numerator, we've got a sum. Those are the individual values. That's the mean of these values. So what's in parentheses there is called a deviation. And we've got 10, and for this data set, we've got 10 deviations, right? We have 10 values, so we have 10 deviations. I'm just going to sum up those deviations. And then I'm going to divide by n minus 1. And then I'm going to take the square root. Before I take the square root, that's the variance. And then I take the square root of it, that's the standard deviation, right? There are certain formulas that are useful to memorize, just memorize them, and it just helps you understand things down the road. This is one. This is one of those that I should ask graduates right before they get the diploma, like before you get your diploma, ask them a question about oxidative phosphorylation and ask them this. If you can't answer it, right? Anyway, so now let's implement that. I'm going to make a column. First, I need to compute the mean. Right? So here's my deviations. That's the individual value minus the mean. So I'm going to click on that row and I'm going to subtract the mean. Right? Look what happens when I fill down. So cell C2 minus cell C13. The mean is in cell C13. When I go down to this next cell below it, right? It's C3, that's correct. That's the individual value. But now it's subtracting the whatever's in cell C14. It's subtracting that cell right there. If I go down 2 cells, it's subtracting the value in that cell right there. So that fill down didn't work properly. What we want to do is we want to make that the cell containing the mean constant. And what we want to be constant is the row number. We always want it to be row 13. And we make that row number constant with a dollar bill sign. So I go back up to my formula, and that's the cell containing the mean. I want to make the 13 constant because it's always in that row. So I'm going to put a dollar bill sign in front of the 13. If I put a dollar bill sign in front of the C, I would be making the C constant. If I put a dollar bill in front of both of them, I'd be making that individual cell constant. No matter where I put the formula, it would always be cell C13. All right. So now that I have that dollar bill sign there, I need to refill down. And I can check, make sure it's correct. That cell minus this cell. So there's correct. There's my deviations. Right? Those dollar bill signs are super powerful ways of using Excel. If you don't know, if you haven't come across a dollar bill sign, learn it. The dollar bill curve, right? You can't be a good spreadsheet user without using that. All right, so there's our deviations. Now we want our deviation squared, right? So it's just that cell. The little caret symbol, that's the operator to raise something to a power. That's in any kind of a programming language. Caret is raise it to a power. We want to raise it to the second power. Square it. Right? So now we want to sum the squares. So, oops, I forgot something in there. Man, nobody checked my formula. Don't memorize the formula I told you to memorize. Memorize that one. What? No. Man, that's right. You would have I would have been out of here. All right. That's what happens when you write a formula part way and start describing different parts of it before you finish it. All right. So now we want to we've got those square deviations. Now we just want to sum them. Right? So we're going to sum that column. And our count our variance is the sum of the squares divided by, and here I need to use the parentheses, right? I can't do count minus 1 because the order of operations would be we do the division and then we subtract 1. That's not correct. We want this, we want C15 minus 1 to be the whole denominator. Do I need to put that in parentheses? Whatever goes into parentheses takes precedence in the order of operations. All these things you learn in math at some point. I don't know when that's taught. It matters. You might not think, man, I will never use this. It matters. And standard deviation, square root. All right. Mean, sum of the squares. There's the count. The sum of the squares divided by the count minus 1 and the square root of it. All right. What reason why I wanted to do this is it just gave me an opportunity to show that the power of that double, right? Very often we're going to fill right, or fill down the formula, but we want something to stay constant. That's what that dollar bill sign is used for. All right. I'm going to put a dollar bill sign in front of the in front of the column, not the row, right? So now when I fill, I'm taking this cell and I'm subtracting that cell. Now when I fill right, I'm subtracting this cell from each of these. 9 minus 14 is minus 5. 10 minus 14 is minus 4. So I've kept that row constant. But notice that if I go down, all right, 4 minus 14 isn't 4, all right, because now it's not referring to cell C3, it's referring to cell C4. The reference dropped with it because the row number wasn't held constant. So let's go back up to that first cell and put a dollar bill sign in front of both the row and the column. Now I can fill right. And then I can fill down. And I've now subtracted that one number from all of the numbers in that little table of numbers with the dollar bill sign. Right? Super, super useful. All right. I've got 3 minutes. Here's a daunting set of equations there. All right. And there's no way I'm going to be able to complete that in 3 minutes. But you're going to, those equations are equations to show how a population of prey, like rabbits, and a population of predators, like lynx, how the population numbers change over time as lynx eat rabbits, there's fewer rabbits to eat, so lynx populations drop. With fewer predators, rabbit populations increase. With more prey, predator population increases. With more predator, prey population decreases. You get what's called a predator-prey cycle, right? And the purpose here is for you, the student, you have an equation like this. Typically, the norm is to look at an equation like that and just go up and say, and just move on, right? We're going to use better knows to actually get you to gain some intuition about these equations, right? These equations have some variables. What is it? What is the behavior of this as these variables change? We need to know what these variables are. That's going to take too much time, right? But I was going to use this just as another demonstration of dollar bill signs, right? But I'm going to give a whole lecture on this stuff later, and you're going to do a better know where you're going to create these pretty graphs of how populations change in number. That's amazing. When we get into the ecology, we're going to be doing that. All right. So I'll stop there. Right. Look at the assignment. Not a whole lot to do. There's some reading these different sheets on the Excel file, right? And you just got a couple of questions to answer. Just answer it right there in one of the cells. Then turn it in. Right? So it's not a, it shouldn't be that laborious, but you do want to take the time and learn how to use a spreadsheet well. It will serve you well down the road. You too.